What is a limit? In calculus, a limit tells you whether a function has a target as x approaches a number. For example, here we have f of x equals to x squared over 2 plus 1. As x approaches 2, the function is approaching to a value, and we call this value the limit of f of x as x approaches 2. And we denote that as limit as f of x as x approaches 2. So this equals to limit as x approaches 2 of x squared over 2 plus 1. And we can find this limit by substituting x by 2. And this technique is called the cheating rule. So this limit equals to 2 squared over 2 plus 1, which equals to 3. So on the graph, as x approaches 2, the y value is approaching 3. So in general, the notation is limit of f of x as x approaches a. And to find this limit, we use the cheating rule. So we substitute the x by a. So this limit equals to f of a. Let's look at a few more examples. Limit of 2x cubed minus 1 as x approaches 2. So to find this limit, we use the cheating rule and substitute x by 2. So this limit equals to 2 times 2 cubed minus 1, which equals to 2 times 8 minus 1, which equals to 15. And the cheating rule also works with trigonometric functions. For example, here we have limit of sine of x as x approaches 0. So using the cheating rule, this limit equals to sine of 0, which equals to 0. So this limit equals to 0. In the next example, we have a square root. Cheating rule works with all the functions. So here we have limit of square root of x plus 2 as x approaches 9. So we cheat and get square root of 9 plus 2. So this limit equals to 5. In the next example, we have limit of ln of x. Using the cheating rule, we substitute x by e, the constant. So this limit equals to ln of e. And ln of e equals to 1. So the limit of ln of x as x approaches e equals to 1. However, the cheating rule does not always work, especially when we have the form of f of x over g of x, because we cannot have a 0 in the denominator in a fraction. So when we use the cheating rule to this type of function, we can have 3 different outcomes. First one, we can have L, any number, over a non-zero number n. And the limit in this case is simply L over n. However, the second case, we can have a non-zero number in the numerator and 0 in the denominator. And we know that we can never have 0 in the denominator in a fraction. So this limit does not exist. More specifically, this limit is either positive infinity or negative infinity. Since as x is really close to a, the y value is any real number over a really small number, which will result as a really large number. So the y value will blow up to either positive infinity or negative infinity. In this case, when y equals to a, we have a vertical asymptote. In the third case, when we use the cheating rule to this type of function, we can get 0 over 0. In this case, we have no conclusion. It means the cheating rule does not help, and we need to go back to algebra. Let's look at a few more examples. Limit of x plus 1 over x minus 1 as x approaches 2. The first thing we need to try is to use the chaining rule. So when we substitute x by 2, we'll get 2 plus 1 over 2 minus 1, which equals to 3. So here we obtain type A, any number over a non-zero number. So the limit is simply L over M, which is 3 over 1. Let's look at the next example. Limit of x plus 1 over x minus 1 as x approaches 1. We substitute x by 1 and we get 1 plus 1 over 1 minus 1, which equals to 2 over 0. But we cannot have a 0 in the denominator, so this limit does not exist. And y equals to 1 is a vertical asymptote. And this is type B. When we get type C of the results, it's more complicated. When we get 0 over 0, it means the chaining rule does not help, and the chaining rule is inconclusive. So here are a few methods you can try when you get 0 over 0. The first one, try to simplify the function. Second one, try to expand if there's any differences or sum of squares or cubes. And if none of this work, then try the third one, complete the differences or sum of squares or cubes. Let's look at an example that applies to each of the methods. So the first method is to try to simplify the function. For example, limit of x squared plus x minus 6 over x squared minus 2x as x approaches 2. The first step, we always need to try the chaining rule. So if we substitute x by 2, we will get 4 plus 2 minus 6 over 4 minus 4. So we use the chaining rule to get 0 over 0, which is type C, so it's inconclusive. Now we need to go back to the algebra. So in the numerator we have x squared plus x minus 6. It's a quadratic, so we can simplify that. 1 times 1 equals to 1, and negative 2 times 3 equals to negative 6. So the numerator, we can simplify this as x minus 2 times x plus 3. So let's go back to the limit. This limit equals to limit as x approaches 2 of x minus 2 times x plus 3 over. The denominator, we can simplify this as x times x minus 2. So the x minus 2 in the numerator can cancel out with the x minus 2 in the denominator. So then we can try the chaining rule again. We substitute x by 2. So the numerator is 2 plus 3, and denominator is 2. So this limit equals to 5 over 2. Let's look at the next example. Limit of x squared minus 25 over x squared minus 5x as x approaches 5. So first we need to try the chaining rule. If we substitute x by 5, we'll get 25 minus 25 over 25 minus 25. So again, we get the form of 0 over 0, which is inconclusive. So in the denominator, we have x squared minus 25, and 25 is 5 squared. So in the numerator, we can expand the differences of squares. So this limit equals to limit as x approaches 5. Numerator is x plus 5 times x minus 5. In the denominator, we can factor out an x times x minus 5. So the x minus 5 in the numerator can cancel out with the x minus 5 in the denominator. Now let's try the chaining rule again. We get 5 plus 5 over 5, which is 10 over 5. So this limit equals to 2. Now let's look at the last example. Limit of x minus square root of 3x plus 4 over 4 minus x. Let's substitute x by 4. Numerator is 4 minus square root of 12 plus 4 over 4 minus 4. So again, we get the type C of the results. Here we have a square root in the function, and usually square root is a good hint to use method 3 to complete the differences or sum of squares or cubes. So here we have square root, so we need to use the square to get rid of the square root. So the trick here is to times either the numerator or denominator, the one that has the square root, and change the sign to plus. So times x plus square root of 3x plus 4 over, same thing, x plus square root of 3x plus 4. So this limit equals to limit as x approaches 4. In the numerator, we have a minus b times a plus b. So numerator equals to a squared minus b squared. And a in this case is x, so a squared is x squared minus b squared. And b in this case is square root of 3x plus 4. So b squared is 3x plus 4 over 4 minus x times x plus square root of 3x plus 4. So we can simplify the numerator and rewrite this as limit as x approaches 4 of x plus 1 times x minus 4 over, let's factor out negative 1 from the 4 minus x. So the denominator is negative x minus 4 times x plus square root of 3x plus 4. So the x minus 4 in the numerator can cancel out with the x minus 4 in the denominator. Now let's try the chain rule again. We substitute x by 4. So the numerator is 4 plus 1 over negative of 4 plus square root of 16, which equals to 4. So this limit equals to negative 5 over 8. So that is an introduction to limits. If you have any questions, please comment it below, and I will see you in the next video.